Hello, and let us begin with the very first lecture on the corporate finance. And we begin here with the time value of money. Let us now understand what does this time value of money mean, and what implication does it have in the finance. Now, say for example, a person has $100, and uh, say for example, the person has $100 today, and he goes to the bank and asks him, what interest rate would you provide me if I invest it in the bank account. The bank says that the interest rate that I will provide is, say for example, 5% per annum. He decides to invest this amount for a period of, uh, say for example, 1 year. So at the end of the 1 year, what is this investment going to be? Uh, it is going to be simply 105. So this investment becomes 105 after investing for 1 year. Now, the investment today, in finance terms, this is known as present value, and what the investment has become after a period of 1 year is known as future value. Now, how do we calculate this? Future value is equal to present value into 1 plus interest rate raised power time t. Now, uh, since the present value was 100 and the interest rate was 5%, and it was invested for a period of 1 year, therefore the investment becomes $105 at the end of the 1 year. Now, let me make some changes into this scenario. Let me now change it a bit. Say for example, the person has $100 today, and the bank says that the interest rate is 5%, uh, but it is compounded, say for example, quarterly. So what is going to happen to this investment if it is invested for a period of 1 year? Now, using the same scenario, future value is equal to present value into 1 plus interest raised power time t. I have to make a certain changes into it. That is that I have to divide the interest rate with the number of periods. Since the number of quarters in a year are 4, so I will divide it by 4 and multiply the time with 4, which means that the formula will now become future value is equal to $100, that is the present value, into 1 plus interest rate is 5%, that is 0.05 divided by 4 for a period of 1 year into 4. So this is going to give me the present value, the future value, if the amount is invested for a period of 1 year, but the compounding over here is quarterly. Now the investment, so in this scenario is going to give me the investment after a period of 1 year when the compounding is done quarterly. Now, in a similar manner, say for example, the same $100 is invested for a period of 1 year at an interest rate of 5%, but it is compounded semi-annually. What is going to happen in this case? Now, $100, 1 plus rate of interest is 5% divided by 2 for a period of 1 year multiplied by 2 times compounding, it will give me the amount that is invested, that the amount that it is going to become after a period of 1 year. So let me calculate it. It is going to be again $104.04. So this so $104.4 I'm going to get after a period of 1 year when the compounding is done semi-annually. Let me think of the opposite scenario. Say for example, a person needs $2,000 after a period of 3 years. Now he goes to the bank and asks him that I need $2,000 after a period of 3 years. What is the amount that I need to deposit today so that after 3 years I'm going to get the amount equal to $2,000? If the interest rate that the bank is providing is 10% per annum. Now in this case the 2000 is not the present value, it is the future value that this person needs after the period of 3 years. So using the same formula, that is future value is equal to present value into 1 plus interest raised per time t. I have this present value but I need to calculate this. Therefore $2,000 is equal to present value into 1 plus interest rate is 10% for a period of 3 years. So if I divide the $2,000 by 1 plus 0.1 raised per time 3, it is going to give me the present value. Let me calculate it. So today this person has to deposit $1,502 into the bank, and after the period of 3 years he is going to get $2,000. We can do we can change the scenario when the compounding is done quarterly or semi-annually or monthly, similarly as we did it previously. Let me now change it to a scenario of compounding quarterly. Now the investment that he needs is $2,000. The interest rate is 0.1%, 0.10%, sorry, it is compounded quarterly, so I have to divide by 4 for a period of 3 years, and there are 4 quarters in a year. So this is going to give me the amount that this person has to invest today. So let me calculate it. So the person has to deposit today $1,492. In a similar manner, you can do it when the compounding is done semi-annually, or the compounding is done monthly, or the compounding is done daily, depending upon the scenario. Now let me talk about another scenario. Say for example, a person has $100 for consumption, but what he decides that let me not consume this $100 today, let me save it for a period of 1 year, and let me invest it into a bank at a rate of 10%. So let me say for example, for the consumption, say for example he has to buy a burger, say for example a burger for $100 today. Now, what he does, he says that I'm not going to consume this burger today, I'm going to consume this burger after a period of 1 year. But what I'm going to do with this $100 is that I'm going to invest it into the bank at a rate of 10%. So, when he goes to the bank and invests this $100 for a period of 1 year at a rate of 10% interest, it is going to become $110. Now, what does he see? After a period of 1 year, this burger is now not costing $100 because the prices have increased, and this burger is now, say for example, costing $105. So there is an increase of a $5 price in the burger. Uh, Now, what he has, how much he has earned from the bank, that is $10. But uh, this $10, for the among this $10, $5 is to be compensated for the increase in the price, and this increase in the price is known as inflation. Now, what is happening over here? He is earning 10% as the rate of return, and this rate of return is known as nominal rate of return. Let me take you a bit and talk about the international Fisher effect. The Fisher said that the nominal interest rates are equal to the expected inflation plus the real rate of interest. Now, in this scenario, what is the nominal rate of interest he is earning? That is 10%. Why it is nominal? Because he is not actually earning the 10% because among this $10, $5 is eaten up by the inflation. So, if he is earning 10, the 5 is eaten up by the inflation. What is left, that is the $5, and in practically, in the reality, he is only earning the $5 because the among the $10, $5 is being eaten by the inflation. So the amount that he actually earns is the $5. That is the amount that uh, he gets after taking care for the inflation. So the interest rate that takes care for the inflation is known as the real rate of interest.